Okay.
Mm.
Hello, teacher. My name is Sandra, V Group 4, and today we're so excited to present our project on real-time face detection, which was developed as part of our processing course. And here is the overview of our project. The first one is introduction, second one is objective, methodology, result, and conclusion. Before we dive into our presentation, let me introduce to our team first. We have Kim Lai, Sela, Tong Meng, Rongrod, and me, Sandra. First, we start with introduction. What is face recognition technology? Face recognition technology is widely used in security, authentication, and uh, surveillance. Our project is focused on implementing real-time face detection and recognition in video stream. That's all for my part. Let pass to my teammate to continue my part.
So our objective is this project is aimed to create a real-time face recognition system that detect and label individual in video stream and with rectangle around their face. So let's move to our next slide.
Thank you, Ram. For the methodology, our system uses a deep leap and face recognition library for face detection and identification for both CPU and GPU version released on a pre-trained model to locate the face and compare encoding for the identification. For the CPU version, use a deep leap AOG histogram of oriented gradient method efficiency, but it's slow for the real-time video. And the second is a CUDA version. Use GPU to enhance the speed and performance, and is making for the high resolution video. And the last one is the web GUI. We're using a flash based interface that connect with a webcam to the CUDA integration challenge is currently support only for the CPU version, and the setup ensure the flexibility and optimize performance based on the hardware capability. So let's move to the next part, that is a result that is presented by Stella.
This is the result that we got. As you can see, we have one if with GPU and another one with web interface. And as you can see in the video, in the result, you can see we have a simple GUI. Move to conclusion. In conclusion, uh, as we comparing both CPU and GPU method, we can assuming that GPU version is specifically run better than the CPU one. And if we use GPU for rendering a lot, it can improve the accuracy and quality of our system more further. Thank you for my part. For the next part, to demo present by Cầm Lai.
So now I will be doing demoing our project. Let me go on to the code. And so this is the code for our project. I will be running the web UI code. So Python app, app, app py, which will run the code for our web UI. And if you go to a link here, you'll see that it'll go into the browser of a web UI, and we have the webcam, and if you press this button, it'll start the model, which will do will detect the face that's currently on the face webcam. This web UI only is running using the CPU pre-processing, so it is a little laggy. And that's for our CPU and web UI. Now I will be demoing our GPU, the CUDA version. So let me go to run it with CUDA and run a Python gpu.py. I will use webcam for this. So as you can see, this is the GPU version using the GPU processing. It's very faster. It's faster than the CPU version, and it's not lagging very much. And that's all for our demo. Thank you, teacher.